This naturalrefrigerants.com article is being read by an automated voice. Adaptation 2025. Field data confirms CO2. Heat pump chiller efficiency in hotel in Goa, India. By Christina Hayes. Published September 1st, 2025. The first set of field data from a CO2 heat pump chiller system installed at a new 87-room hotel in Goa, India, has confirmed the technology can efficiently deliver hot water and air conditioning in tropical climates, according to the project's development team. Initial observations have shown the system can successfully produce hot water at 80 degrees Celsius, 176 degrees Fahrenheit, while simultaneously providing glycol-water at 2 degrees Celsius, 35 degrees Fahrenheit, for air conditioning. It can deliver heating and cooling capacities of roughly 152 kilowatts, 43.2 tons of refrigeration, and 110 kilowatts, 31.3 tons of refrigeration, with average COPS of 3.6 and 2.6 respectively. These results affirm that CO2 heat pump chiller systems offer a promising solution for Indian hotels currently dependent on separate heating and cooling systems, noted Sarun Kumar Kochuni, a postdoctoral fellow at the Norwegian University of Science and Technology, NTNU. Kochuni shared details of the system's performance during his presentation at the International Institute for Refrigeration's inaugural International Conference on Refrigeration Adapting to Rising Temperatures, Adaptation 2025. The conference was held August 10th to 13th in Manchester, England, and hosted by the Institute of Refrigeration UK, IOR. Data collection. Operational data was collected in December 2024 and January 2025 to evaluate the system's performance under real-world conditions. For the study presented at Adaptation 2025, a representative dataset from January 11th, when the system ran continuously for 7 hours under stable conditions, was used as the basis of analysis. Following the successful operation of the CO2 heat pump chiller at the Goa Hotel, the system's manufacturer, Meters Renewable Energy, has received requests to produce an additional 15 units. While many of these are for other hotel installations, the company said it has delivered a similar system for a dairy application. "We have seen a really good interest because this site is working really well," said Kumadak Sharma, managing director at Meters, who participated in the presentation's Q&A. "For this type of application, we are promoting CO2 as a primary product now." System architecture. The CO2 system combines heating and cooling functions within a single unit, supported by a 6,000-liter, 1,585-gallon hot water tank and a 1,000-liter, 264-gallon cold water tank. A thermal energy storage TES unit on the heating loop buffers excess hot water and applies thermal stratification to maintain stable supply temperatures. Automated controls ensure reliable operation under fluctuating hotel demand. Key components include a variable frequency drive compressor, plate-type gas cooler, internal heat exchanger, and ejector. The ejector enhances efficiency during transcritical operation, a frequent condition in tropical climates. During operation, compressor discharge temperatures averaged 104 degrees Celsius, 219.2 degrees Fahrenheit. The gas cooler maintained outlet water near 80 degrees Celsius, assisted by the TES and control system to balance varying loads. Cooling is delivered through 2 evaporators in series, the first gravity-fed and the second controlled by an electronic expansion valve. This staged setup enables return water at 15 degrees Celsius, 59 degrees Fahrenheit, to be cooled effectively to as low as 1.5 degrees Celsius, 34.7 degrees Fahrenheit. A glycol-water mixture circulates in the closed cooling loop, transferring chilled fluid through the evaporators and the hotel's air handling ducts. To ensure replicability, the manufacturer tried to keep system design simple, explained Sharma. Made in India. An important aspect of the Goa Hotel project is its domestic development. Meters Renewable Energy designed and manufactured most of the CO2 heat pump chiller system in India, including the control system and key mechanical components. This allowed the unit to be tailored to the demands of a hotel in a tropical climate, while also minimizing costs. The control platform, based on a Siemens PLC with a proprietary SCADA interface, enables continuous data logging and remote monitoring. This ensures stable operation despite the hotel engineer's limited familiarity with CO2 systems and allows adjustments to be made in response to varying demand patterns, such as morning peaks in hot water use and higher cooling loads during the day. On the hardware side, meters fabricated the liquid receiver, oil level controls, valves, and other components locally, while only the compressor, ejector, and plate heat exchanger were sourced from abroad. ND Plus Project. The hotel installation was carried out under NTNU's ND Plus project, an Indo-Norwegian initiative funded by Norway's Ministry of Foreign Affairs. The program aims to demonstrate the feasibility of natural refrigerants in India's HVAC and R sector through real-world applications. Traditionally, Indian hotels have depended on HFC-based chillers for cooling and fossil fuel boilers for hot water in showers, kitchens, and laundry. By contrast, a CO2 heat pump chiller integrates both functions, recovering heat from the cooling process to simultaneously supply hot water, thereby improving overall energy efficiency. Despite this potential, adoption in India has been limited due to concerns over system performance in high ambient conditions and the lack of operational data from commercial buildings. Such data is crucial to validate their low-emission performance, assess real-world efficiency, and promote cost-effective sustainable heating and cooling solutions in India's commercial building sector, the project team explained. Earlier modeling under INDI Plus suggested that a hotel in Chennai could reduce annual operating costs by 93% and CO2 emissions by 80% by replacing diesel-fired water heaters with R744-based heat pumps combined with thermal storage. The current field results in Goa provide the first publicly available validation of the technology's potential. Future studies under the NDE Plus project's follow-up program, NDE 3, will examine operational flexibility under varying seasonal load conditions.